So nice to meet you guys. This is Changmin. As I said, I'm based in Tokyo. I work in Mercari, and I work in the team called AI LLM team as a software engineer, but I'm doing a lot of stuff from ML to DevOps and other stuff. Today I'm going to talk about LLMOps and LLMOps actually, but I'm not going to talk like we do have best practice, you guys follow it, because this topic changes a lot. What's true today cannot be true tomorrow, right? So I'm just humbly share what we learned from our journey, and you guys can pick it up something, yeah. So I guess many of you guys never heard of Mercari before, even though we have like US branch, but we're basically mostly based in Japan. We're starting from like C2C e-commerce platform. Now it's like largest C2C e-commerce platform in Japan, but rapidly expanding our businesses horizontally, such as fintech, crypto asset, MVNO. And monthly active user is about 23 million, which is 98% of all e-commerce users in Japan. So if you guys are interested in Japanese stock market, buy stocks, so I can sell my shares. Yep, so let's go to the topic, LLMOps development. So there are several ways to see it this way, but we've primarily defined like three major components. First is model. Of course, if you want to build the LLMOps, you need a model, right? And then the data. You need like user input, pre-processing, post-processing, and prompt engineering, of course, like lagging some knowledge base. Also these days, a lot of MCPs. And lastly, evaluation. Before you productionize your app, you need to evaluate to know whether it's working or not, right? So with that being said, we can take different approaches. First one is like model-centric. Of course, you focus on the model, which means that you retrain or fine-tuning based on your purpose, which makes sense. The second is data-centric. For example, you embed all your knowledge bases into vector database and use it as a lagging, or you set up a lot of MCPs, or you do a lot of post-processing or pre-processing of user inputs. And the last, eval-centric. This is the point I'm gonna talk about throughout all the slides. Actually, LLM requires eval-centric according to our experiences. For example, I think you guys have heard of like LLMOps are easy to demo, but hard to productionize. In this case, like this kind of like a customer-facing chatbot is very ambitious, not because LLM's performance, but because also we don't know what's good and bad, which means it's hard to evaluate, right? With that being said, LLMOps development requires eval-centric approaches. What do you mean by like building an eval? Which means that you build something to help build something. So evals are like enablers, don't like lack building them. So when you do eval-centric, you require LLMOps. But don't get me wrong, like when people talk about LLMOps, they talk about like a very like complex stuff, like you need a feature store, you know, retraining pipeline that is triggered based on performance generation or like data decay. You need analytic tools, monitoring, and so on and so forth. But that's also correct. But what's the point of this LLMOps, MLOps, like FinOps and DevOps, all the ops? It's a faster iteration. You need those certain kind of process to iterate really fast. So with that being said, just like software engineering, we need those kind of process for when building LLMOps. First, evaluating quality, like you do in software engineering, you do like unit tests, right? The second is debugging issues by using loggings or inspecting data. And second, the last is the changing behavior, like writing code, fine-tuning, and prompt engineering. Actually, many people focus on like number 3 above, but actually that prevents the users, the developers from improving their LLM products beyond the demo. So once you have a like very good evaluation pipeline, everything's come along. So up next, I'm gonna talk a little bit about the LLMOps we're using up and running in Mercari, also about our team. So as I said, Mercari is a C2C e-commerce company. There are like many core teams, but 2 major core teams are like seller experience and buyer experience. At the same time, since it's like C2C e-commerce, it's a like high probability that user can list an item that is illegal or suspicious. So we pay much attention to TNS, trust and safety. Also, we provide a fintech or payment service. Also, not only the C2C item, we also allow business users list their item to provide a seamless buying experience to users. Also, cross-border, which means that you can buy an item out of Japan. So along with these core teams, my team, AIM team, work closely with this core team, maximize their business impact, mainly using Gen AI. So here are some LLM apps up and running right now. First one is content moderation. We actually traditionally using rule-based model, also ML models for content moderation. But we trying to combine with LLM apps with this like ML models, which I will talk about later. And also for seller experience, we do have two major features, metadata extractor and the AI listing. What they're doing is actually same, but it's a bit different in terms of the timing. This metadata extractor is asynchronous. So we extract some metadata based on the images and then suggest the users to change their metadata if item is not sold for like a week or something. But AI listing is something, when you list an item, you upload an image, and then based on image, this AI listing feature detects some like context from image, and they write down item title, description, pricing, metadata. So as you can see, for metadata extractor, it's asynchronous, which means that we can control the traffic flexibly. So we were able to use fine-tuning LLM, but for AI listing, we didn't use fine-tuning LLM because when you productionize LLM, performance is not always everything. You need to consider about like infra cost, latency, and other stuff. So like we don't have like much GPUs, so we found out that the performance gain from fine-tuning LLM, considering the like infra cost and latency is not that high, considering just using LLM APIs. So we don't use fine-tuning LLM for AI listing. So for buyer experience, we also actually had a chatbot straight recommendation, which is like customer-facing chatbot, but it didn't go to production, to be honest, because of like we find trouble to build up some evaluation for this kind of chatbot. Also, we do have a lot of agents for internal use, such as DevOps, which is embedding all the internal documents in the company, and then provide some best practices for software engineers to increase their productivity, along with like other productivity tools such as Cursor and Windsurf. And so we are like Japanese company, but most of the engineers non-Japanese speakers. So we do have like a lot of translation agents, and the HR agent, also agent for self-evaluation. So with those LLMs, we can see in two different ways actually. That problem solved with traditional way, with software engineering and ML, is easy. Not because it's technically easy, just because we know what's good and bad. We have very strong, like the ground truth data about it. And the other stuff, actually the problems we have never solved, which means it's difficult because we don't know what's good and bad, which means that we need more evals. So for example, let's take a look at content moderation. This is a very simplified version of like content moderation pipeline. When user reads an item, this ML model picks up an event. There are several ML models per category and decide whether item is suspicious or not based on the features. And then if it's detected as suspicious, the operator is finally checking whether item is suspicious or not, which is labeling. Based on labeling data, we do retraining ML models on our MLOps. And actually, when they label those items, not only they use their like experience, but also they need to use knowledge base because sometimes it's related with the Japanese law. But ML models don't know about this knowledge base. So we deploy the one LLM apps, which doesn't have any fine tuning, only a system prompt, plus lagging the internal documents. So by doing so, we can use the same knowledge base with the operators. And if up and running is quite well, in terms of overall cost, it's quite decreased. So we are expecting to expand these LLM apps to other categories too. This is a very successful case on our case. So another example is like this actually buyer experience, which is customer-facing effort. As I said, this is quite difficult just because it's hard to build evals for this one. So it didn't go to production actually. It failed in the like POC level. And another example is AI listing. This is up and running quite well. It's like now it's one of the core part of our business. The concept is very simple. One of the obstacles that preventing user list an item is that when they list an item, they need to write down all the details like item title and description and pricing and metadata. So instead of that, when user upload an item and then you decide a category, and based on that, the LLM app write down the system, write down the item title, description, also pricing, and the metadata. So when we build this app, we come up with this pipeline first. First, create a prompt. This is very true for every like LLM applications. It doesn't have to be very complicated. You can just come up with a simple script that consists of for loops and the combination of several models and then prompts, which is called these days as a vibe check. And then go to the next level, which is automatic eval within the team. We set up like some very simple evals and then run some evaluation and pick the best out of it. And then go to the domain expert feedback, because these LLM apps tend to be focused on very specific tasks. In that case, actually that requires some domain-specific knowledge. So we have a lot of collaboration chances with domain experts. So after that, we iterate this process and so on and so forth, like several times. Once it gets to a certain level, we deploy the model and the monitor. So for example, for model and prompt, this is a real prompt we are using right now. But of course, we use different prompts per category. And input is the image, output is title, description, item, attributes. Of course, it's involved with some function calls, actually. So after that, we get some vibes and then move to the heuristic matrix. We sample some good listings of Mercari and then come up with a heuristic matrix. And then along with some traditional metrics such as blue and large. And also we have like binary classification evaluation, such as like a Japanese detector, whether it is written in Japanese or not. Even though we strongly instructed that please write down in Japanese, sometimes the model is trying to write down in English. So this is not everything, but this is a very good starting point. And then we move on to the LLM as a judge. I know how many of you guys are familiar with this term. So let me explain simply. This is very simple, actually. So you let LLM evaluate your LLM, right? So there are a lot of open source, such as GEval, Prometheus, but I'm not going to get into the details. So you can refer to papers like this one. Also, we come up with some custom prompt for scoring and the binary classification for performance of an LLM app. And then throughout this process, we found out that some categories suffering from hallucination. That's because of lack of training data for certain categories, such as trading cards. So we need to add another evaluation called grounding, which is called fact checking. For that one, we didn't come up with a tool. We just used a tool API from Vertex AI. And then after going through all the evaluation, the final part is always domain expert check, which always needs human feedback. And actually, we came up with an in-house tool, but I'm not allowed to show in this conference. So I just pick up one of our partners' product, which is Lens. As you can see, this is very straightforward, intuitive, providing a UI tool that domain expert can evaluate the performance of LLM apps. So here are key learnings. You don't have to be too ambitious from the first. Start with the small data for vibe checks. And then set a threshold and do tiered evals. Because as I said, LLM as a judge using LLM to evaluate LLM, which means it costs double. So you first filter out some best models, best prompt with heuristic evaluation, and then move on to the next level and do tiered evals. And during evaluation, sometimes if you think something is not going well, evaluate your evaluation. And while you evaluate, actually, you need to use a lot of tools. Use tools if there is. If not, make tools. Now it's easier than ever to come up with a tool thanks to LLM, right? So attention is not all you need, actually. Sometimes evals are all you need. So lastly, I'd like to provide some action item for you guys. As I said, LLMOps tend to be so focused on very specific matter, which requires feedback from subject matter experts. So we need to collaborate with them as an engineer. So if you want to scale your LLM apps, you need two things: evaluation, of course. And then for evaluation, you actually need to use a lot of tools. By combining these tools, you can actually scale your application. And then, some people say LLMOps is quite complicated, but we didn't go through all those tools, actually. Even if you don't need these tools at first. Maybe it needs some time, some days, but. So start simple. Just come up with a few scripts, testing your models and system prompt. and then grow to the needs of your problem and your team. For example, in our case, we start with a Git and the JSON blobs, even like for loops for testing, like for the vibe checks. And then for SMEs, at first we used a spreadsheet because data set was very small at first, and then come up with a simple UIs for human feedback. And if the need is growth, and if you need more tools, then we start using like external tools, such as Weave. So this is the workflow we followed throughout the LLMOps. From developer side, you need to validate MVP first, come up with like system prompt at first, and then integrate observability, reproducibility into your app using your tools. After that, you start adding more evals. And then I'm gonna go through like I'm gonna visualize how we come up with these processes, but it's not the actual data, only just visualizing it. So one of our engineers started the MVP with the different models and prompt. And then throughout this weave, we can keep track of all the like models and system prompts. And also you can check the diff of the input data, also output data, and then prompt management, of course, and the code versioning if you're using the function calls. And also, throughout this MVP, you're not going to use only one data set. You're going to use several data sets. And this we will provide like a data management too. You can check the details of data set, which is very helpful. And also evaluation, this is the most important thing. You can simply like visualize by the tables or the other stuff. We added like scoring system, binary classification, and so on and so forth. So with this observability and reproducibility by the tools, we can iterate quick. In our cases, so one engineer was in charge of this task, and then he ran like 20K lines within a week. So for example, in one day, he came up with the MVP, and that's like team confirmation from EM and PDM by providing this visualized data and evaluation, and they get some feedback in the very few minutes thanks to the visualization. And the very same day, he was able to reproduce everything thanks to the Weave, and then finally get the final confirmation within the team, and then move to the next level, which is domain expert check. So for SMEs, you can start with a built-in metrics. Built-in metric means that if you use a tool, actually, they provide some built-in metrics based on like some experience. Or if there is no built-in metrics, you can provide SMEs from baselines. And then they start to create like human feedback based on their knowledge about specific matter, and then move on to the custom metrics using the prompt. After this, you achieve alignment between metrics and the human feedback, and then iterate quickly to improve quality and so on and so forth. And then once it reaches a certain level, you can okay to deploy and productionize. So as I said, I'm not allowed to share our internal tools, but instead, I brought one of our partners' tool, which is called Citadel AI's Lens. As you can see, they provide some built-in metrics for LLMOps. Also, they provide some custom templates for come up with their own custom metrics. And then this for like human feedback, very intuitive. So there are like takeaways. Don't be ambitious from the first. Start with a strong foundation, whatever it is, and then secure the observability and reproducibility, whatever tools you have for quick iteration, because quick iteration leads to success. And actually, all I want to say is about evals, actually. Evals. There are a lot of good open source and good papers you can reference to. And sometimes, from our experience, good evals can beat the ragging and fine-tuning. So here are like some open source and papers we referenced throughout the LLMOps development. Then what's next? There's no secret that even LLM like base model developing companies like OpenAI suffering from lack of evals, so which means that we need better evals now more than ever. So think about how many job interviews you've been through to get your job right now, and think about how LLMOps go productionized without evals. And like all the works throughout these slides are done by my wonderful teammates and the previous teammate, Theo, and other community readers. There are some resources. That's all from my side. Thanks for listening.